All right, everyone. So, good evening. My name is Senri Margidara, and I currently overlook university relations for creative software. First and foremost, thank you so much for taking the time to join us for today's session. Talking a bit about creative software, first and foremost, we have been in the tech industry for about 25 years now, building and managing high performance software development teams. And if you all went through the flyer that we shared with you all would have seen this logo called Creative Spark. So I'll talk a bit about what Creative Spark is. So you all would also get an idea of this initiation of ours. So as most of you all know, we work with a lot of universities across the country on various levels. And this initiation and collaboration of ours is called and branded as Creative Spark. So everything we do around this space, say in internships, fresh grad placements, field visits, tech talks, and a lot more actually happen through these initiatives. So we also do have an Instagram and Facebook page. So do give us a follow as most of our university efforts go through this. And you all will be able to stay connected with us, especially now, for example, these tech talks. And also if we do have an internship opportunities, all of this will be placed on these pages. So do give us a follow and stay connected with us. Diving on into today's session. So today's session will be around the space of microservices, and it will be done by Sashitha Fonseka, one of our senior software engineers at Creative Software. So over to you, Sashitha, and really hope you all would take part in the upcoming sessions as well and stay connected with us. Thank you so much again.
All right. So hi, everyone. First of all, thank you so much for joining in. I really appreciate you guys taking the time to join us today. The topic for today would be on a very basic introduction to microservices. So we are going to talk about why we selected this topic, because we see a lot of potential and demand in the industry based on what we've seen in the recent years, with a lot of projects moving into microservices. So we're going to talk about it and give you guys some kind of introduction to hopefully explore what this architecture can offer. So just to be clear on the target audience for today, I share my screen. So we are not expecting you to have any understanding of microservices. It's this webinar is for absolute beginners. And some understanding of programming would certainly help, but it's not mandatory to keep up because we'll try our best to kind of go from the very basic. And we are not doing anything too complicated today. This is going to be just an introduction, but hopefully good enough for you to explore this architecture more. So the first question that would come is why microservices and why have we selected this as a topic? So as I said, in the recent years, there has been a lot of demand in microservices that we've seen. But if I just pull out a couple of statistics from some surveys online, one is about is that 85% of the respondents from a large organization, so they consider people within more than 5,000 as a large organization to be using microservices. And 92% of organizations that are using microservices are quite happy of the fact that they have now kind of adhered and moved into using microservices. And on the right-hand side, you have some prominent logos that hopefully you can relate to. We have Netflix, Uber, and Spotify. All of these organizations have also taken the decision to move into microservices. So hopefully, when we wind up the session, you'll have some kind of understanding of the benefits that this architecture would offer, which would have encouraged so many organizations to go. And just to share my experience as well, now this is my second project that I'm working with in creative software. So the first one was actually a project on the e-health domain, and my current project is actually is an enterprise application. And when it comes to the two domains in itself, they're extremely different when you consider the domain wise. But one thing common in both is that even my previous project, which was the health product, they also decided to move into microservices. And my current project is also in a transformational phase where they're also moving into microservices. So that in itself should give you some indicator that there's a lot of demand for this. And it will genuinely help you solve some problems in the industry today with the type of application that we're building. I'll walk you through the agenda for today. We're going to start off with an introduction to what microservices is all about. We'll look at the key components of a system that uses and adheres to microservices. And just like anything, when it comes to implementing an architecture, in order to do it in a productive and meaningful way, we are going to have to use some technologies and tools. So we're going to talk about those. And I'm going to share, the tools and technologies might be a little bit overwhelming, particularly if you are an absolute beginner just going to start it. So I'll share what I would consider as a hello world to kind of get yourself started in microservices, which is hopefully like a pet project that you can try to do. And I'll leave behind some takeaways based on what we learn. So the first question, what are microservices? And to explain this, I'm actually going to use a small business case to try and walk you through a analogy that hopefully you'll be able to, by the end of this, you'll be able to understand what microservices is about. So the example we're talking about today is something called Cineflix. So imagine we have two friends who decided that they want to they had a vision of wanting to basically distribute movies. So it's a movie distribution platform. Don't confuse this with Netflix, but this is maybe something before Netflix actually came into the picture. The idea is that they simply wanted a way to distribute movies across people. So they're fans of movies. They want to distribute movies across themselves first, and then eventually with their friends. So the objective was to really have a mechanism where somebody can request for a movie. And given that this is all done legal, because I know this example might not be very realistic, given that the movie domain is very complex legal-wise. So let's forget about all of the legal complexity. Let's assume that they have some kind of license that allows them to do this and distribute movies. So the idea is that they have a list of movies that they maintain, that they have the license to distribute. And people can request these movies and they're able to kind of give them the opportunity to watch those movies for a given period of time, and they do charge a fee in order to do this. So let's start with a really unrealistic yet simple example, which is probably the first approach here was to build a terminal-based, very simple application. So the idea is as simple as it gets. The application is just like the hello world that we do in first year uni projects. So you have a menu option that comes up. You can click the first option to see what the movies are that you can basically request for. And the requesting process is as simple as it can get. You just need to click the option to request a movie, then type what the movie you want, and fill in some contact details. Ideally, what you're going to get is an email with a link to make the payment. And once you do the payment, you'll receive another link to watch the movie. So that's how they started the project. And this worked for a while. This worked when they were just sharing it with their college friends and everything. But eventually, they had some issues. So let's try and understand what the issues were. So the first problem with the terminal-based solution that they had was that it was a very bad and terrible user experience. So why is it a bad user experience? Because now, if you look at the technology that we have right now, we have great technology to do front-end work, and we have very powerful technology to do back-end work as well. So using a terminal-based approach isn't the most appealing way to present an application. So that was bad user experience. So with the console-based approach they had, all of the client code. So in this case, when I say client, the terminal itself is acting as a client. So the client code and the business logic was all tangled up together. So segregating that was also difficult. This makes debugging problems difficult. This makes it hard to maintain. And also they were not persisting data in any database, in any external data. So all of that was in memory. And they had requirements from now, since the platform has become a hit, now people see a need for it. They had requirements from people to basically be able to access this service over the web. So they had to rethink their design, and what they came up with is what hopefully most of us would be kind of comfortable with seeing, which is the three-tier architecture. Now, the three-tier architecture can be more complex than this, but to keep things very simple, let's use the most basic version of this tiered architecture, which is the presentation layer, which is essentially what somebody can see. And in terms of the type of device that somebody would be seeing it, we call it the client. So it can be a mobile client, a web client, a desktop client, depending on what you're building that application for. In the middle, we have the application tier, which is where most of your business logic would remain. Various services would be there. So we talk about the client server architecture in this context. So this is where your services would be there. This is the part that would typically be when you segregate your data onto an external place, onto a data tier, you put it in some database. This application tier is the one that would be communicating with your database in order to retrieve stuff, do the CRUD operations basically, create stuff, retrieve stuff, update stuff, and delete stuff. So they decided to upgrade their tech stack and they used a React-based client. And for the backend, they use .NET with a Postgres database. All of this seems fine. So let's focus on since we're talking about microservices, let's focus on their architecture server-side wise. So what they did was they exposed the functionality that they had in their terminal-based solution with a few endpoints. If you're not familiar with what an endpoint is, this is in the context of APIs where we can basically expose certain functionalities using what's called REST APIs. When what we say is REST is representation state transfer, and the idea is that we can make certain resources available, we can update and change resources using API calls. And to access an API, we need something called an API endpoint. So in this case, kind of using the same example of the Cineflix, how the terminal-based thing was there, they identified a few endpoints that they would need for their solution. For example, to retrieve the movies, when somebody wants to see what are the movies that they can purchase or request from their platform, they would have a movie endpoint, which will retrieve all of the movies that are available. In order to make a request, they would be sending a post request saying that I would like to request for this movie. To do the payment as well, they would enter their payment details and send in another post request. And of course, to log in and log out. For all of these things, we would be sending a request to the relevant endpoint, and that endpoint would act according to the request that we have sent and send us back a response. So that's how the request response cycle works within a typical client server setup. Now, with having this mindset, there's nothing wrong with this approach at all. This is how this was their approach to build the software. There's nothing wrong with this at all. This is a common architecture that is used by a lot of people. But with this understanding, I would like to introduce you to the word that we refer to as what a monolith is. So the idea of a monolith is we are putting all of our components within the application into one single gigantic unit. And that unit is the one that we are deploying, and that is the one that we need to use to develop and to deploy. We are putting all of that in one big container. So let's try to understand what a monolith is and this can have pros and this can have cons as well. So let's try to understand that with a simple analogy. And the one that I'm going to use now is one about a single owner based, a small bakery. Basically, that is a home-based bakery. So typically in a home-based bakery, you'll have, you'll be making cakes, cupcakes. Typically it'll be like one person in that place. You might have a little Instagram page or something set up to get your orders. But the idea is you'll have cakes, cupcakes, pastries, and various types of food that you're preparing. Now, if you think about it, since it's a single owner and a home-based bakery, you will be the one responsible for making the food, for doing all the preparation work. You'll be the one responsible for cleaning all of the stuff once the preparation is done. You'll be the one responsible for doing the finances of your business. So you will be responsible for basically all parts of your system that needs to function in order to get this system up and running. So there are the pros of these approaches. As an individual, you have full visibility of everything because you are the only thing, you have full control of your entire business here. It's easy to maintain because you don't have to deal with other people or have any other involvements. Yes, you might have to depend on others to get your ingredients and everything. But in general, it's easy to maintain because you're the only one who's actually contributing to this business as well. That being said, you're also fully responsible for the outcome. So if you're doing a good job and you're making good food, you'll have good business and you'll have a lot of people coming in. If you're not making good food, the sales will drop. Similarly, for example, let's say you're sick one day, you're not able to do any cooking that day. That means the entire business won't be able to function because you're the only one, you're the one who's running the entire show. And on the other hand, let's say your food has done really well. And now you're getting a whole bunch of requests. You have a lot of people waiting at the door of your house, waiting for you to make some delicious food. That can be overwhelming for you sometimes because now there's a lot of requests coming in. And in order to produce the outcome, it's too overwhelming for you because you're the single unit that is operating in this business. And when it comes to changing certain things, it might not be very, you might not have the capacity to change certain things as well. So with that, if you look at the challenges of a typical monolithic system when we are building software, monolithic systems have deployment complexity. What that means is when we are putting the entire application and bundling it up as one gigantic unit, even to test a small bug fix, we would have to deploy that entire application onto the server in order to be able to test it. So the question is now, typically when we talk about software teams, we follow a methodology called agile, and the idea is that we operate as small independent units, small independent teams. So each team has their responsible. But when in a monolithic system where we are depending on the entire application to be built as one big unit, and we need that to deploy some functionality which is specific to our team, that might not be the most efficient and productive way to get it done. The other downside is if you look at the Cineflex server side that I showed you, that entire thing was based in .NET. That was the example that we took. Now, if for some reason there is a requirement that, okay, we would need a machine learning component for the movie requesting platform so that we are going to capture users' preference to see what types of movies a certain user is interested in, do some content-based or collaborative filtering, or do in some ML stuff. So the popular candidate for any ML stuff would be Python, because Python has a lot of modules to support those things. But in a typical monolithic system, that could be challenging. Why? Because your entire server side is depending on one given stack, or one given technology stack, and you can't really change it. Same goes with dependency. So if you're depending on a certain version of a third-party dependency, you can't say that one endpoint needs to use version 1 and the other endpoint needs to use version 2. It always has to be the same version, otherwise there'll be something called a dependency conflict. So because of this, when teams are upgrading their dependencies, that has a certain problem because each team, even though they're operating individually, internally they still have to depend on each other. And that brings to the fourth point. That means in order to actually release something, everyone has to coordinate with each other and come up with a proper release cycle, because teams aren't able to independently decide when they want to release certain things. They need to coordinate with everybody and come up with fixed release cycles. It's of course difficult to scale it because with monolithic systems, when we talk about scaling software in general, we talk about two aspects. We're scaling horizontally and scaling vertically. With monolithic systems, what we usually can do is we can scale vertically. That means we add in more computing power. We increase the RAM. We can add more CPU. We can add more storage. So we add in more computing power. That is the idea of scaling vertically. So scaling horizontally is when you expand something like add more nodes. So you don't need to add more computing power or RAM or anything. You just expand the number of instances. So that is not possible with monolithic systems. Why? Because the entire unit is together as one. It's all too tangled up. So let's now try to understand with what we just discussed, what are microservices. So this is probably the textbook definition that you're going to get when you Google this from microservices.io. The idea of microservices, I'm not going to read the entire thing, but the highlighted keywords would tell you that each microservice is independently deployable and is loosely coupled. Let's try to understand that in a simpler sense. It's like breaking your application into multiple small applications. So you have one big application or one big container that we saw initially, and that one we are able to break it into multiple small applications. So let's try to understand it, what that means more specifically. That means each service or each microservice that you do is going to specialize in ideally one thing. So it's going to specialize in one thing and be really good at that one thing. It needs to be able to independently function. That means it shouldn't depend on another service to do its functionality. It needs to independently function. Since it's independently functional, that makes it possible to be independently developed. So developers can use it independently without having to worry about what is the tech stack another service is using. They can pick whatever stack they want to use, and they use some development. So we can see some example of it in an architecture a bit later on. And the biggest benefit is that they are independently deployable. So if there is a bug in service A, you don't need to deploy the entire application to be able to test it. All you need to deploy is service A. So that's, I would say, one of the biggest benefits of microservices. Now, if you look at an extended analogy, same home-based bakery that we did, let's assume that now it has actually been converted into a fully fledged hotel or restaurant. So if you think about how a hotel or a properly established restaurant typically operates, there are roles specified to everybody, right? So from the moment you go into a hotel, you meet a receptionist. Then there'll be a waiter to help you out with the order. In the kitchen, you'll have a chef. You have support staff who's helping you out with the cleaning. You'll have somebody in the accounts department who's taking care of the finances. A lot of roles within this ecosystem, and they specialize in those roles as well. So they are able to. The idea is that each role they're able to function independently, but in order to get the whole show of the restaurant up and running, you need everyone's contribution. Everyone needs to work properly in order to get the job done. But they're able to do their role independently. That's the key word that you need to identify. So this is just as working with any team or trying to be successful in a team sport. If you look at the pros and cons, I'll start off with the pros. In a distributed system like this, where we distribute responsibilities across different people, there is going to be less responsibility on one person. So if let's say the person in the accounts department is not feeling well and he or she doesn't turn up for work, that doesn't mean you have to close the entire restaurant. Hopefully you can allocate somebody just for that day to take care of the accounts and to do the finances, but you don't need to close the entire restaurant. And the other thing is, you can always, for example, if it's a day that it's a very crowded day at the restaurant, so you can try to add in more waiters or more support staff to facilitate the requirement, because now there's a sudden spike in the orders and the requirement for that given day. So you're able to allocate more resources if and when needed. Also, now let's say someone in the accounts is actually stealing some cash and they're not doing their job properly. You can independently replace that person. You can tell that person in the accounts to leave, and you should be able to independently replace only that person without affecting the job roles and the responsibilities of everybody else within this restaurant scenario. Just as the pros, we have the cons as well. This becomes you need to properly be able to maintain this, right? Because now it's not about taking care of one person, like the example we saw before. Now if you're the owner of this restaurant, you're responsible for many people. So you need to make sure that all of these people are taken care of. And when you're the only owner of a restaurant, you have full visibility of everything. From start to end, you have full visibility. But when you're distributing responsibility, the visibility decreases. So then that's where trust plays a role there as well. But the idea is that the visibility would decrease when compared with a single person operating everything. And of course, you need to ensure that every person adheres to certain standards. For example, we can't have, in a restaurant type of situation, we can't have somebody who is very good with his hygiene, and another person who doesn't take care of his or her hygiene at all. Right? Everybody needs to adhere to the standard, and everyone needs to take care of themselves properly. A key thing is everyone needs to be in sync about what's happening. For example, if it's a time that the restaurant is getting busy, probably the receptionist would give some kind of indicator to the head chef in the kitchen and say, look, now it's going to be a busy time. Otherwise, what will happen is a lot of people will come in, and if the chef is not updated that there are a lot of people, he'll probably be taking a nap somewhere. And what will happen is that people are just going to be frustrated and upset to see that their food hasn't arrived on time. Two important questions that we need to answer when we are trying to bring the same ideology that we spoke about of distributing responsibility from a monolithic system into microservices. So the first one is, how do we break the services? That can be a little bit tricky, and that's extremely important that you do it properly the first time, because it can have some repercussions later if you don't plan it out properly. So the idea of breaking microservices, usually a practice that has been recommended, is you look at the business functionalities of your system. If it's, for example, let's take an e-commerce type of system, you understand what are the business functionalities that this application can have. For example, the payment part can be a business functionality. Displaying the products can be a business functionality. User management can be a business functionality. When you understand the business functionalities, you try to uh, differentiate services based on the business functionalities in your system. And the idea of those, after you break the services, the idea is that you kind of give the responsibility of that service to a very specific team. And that team should have the capacity to kind of specialize and really master what is going on in that, but going on in that service. Then the next question is, now we have distributed our system into multiple smaller services. How are these services going to talk to each other? Because like I said in the restaurant example, everyone needs to be in sync, right? Everyone needs to be aware of what's going on. Because even though you're responsible and you're working independently, in order to get the whole show running, everyone's collaboration matters a lot. So everyone needs to understand what is happening. Just like in a restaurant example, this is very much the same when it comes to a microservices architecture as well. So there are few different ways of getting services to talk to each other. I'll walk you through two very common approaches for now. So one is we use API calls. With API calls, this makes it a synchronous communication. And the idea of synchronous communication is we have, let's say, in the movie example, we have a movie request service. And let's assume we have a notification service. So the idea is that once somebody has requested a service, and we have processed that request, we want to be able to send a notification to the user saying that your order or your request has been processed. Now you can do whatever you want based on the notification that we're sending. So one way to accomplish it in a microservices, the order service would be actually one separate service, and the notification service itself would be another separate service. Now the question is, how do we get these to talk to each other? So the first approach is we can use service to service communication using API calls, using REST API calls. So we have an endpoint that we can expose. So service, in this case, the order service will call a post endpoint probably in the notification service and send a post request saying that, okay, post this request. Another way to do is, and a more performance oriented way of doing this is using remote procedure calls. You can use something like gRPC. So if performance is of absolute criticality for you, you can use gRPC to send a remote procedure call. So they use a technology called HTTP2, which is known to be better performance wise. So you can Google about it on some statistics to see the comparison that people have done. So that is one way to do it. But the problem with both of these approaches is this makes it synchronous. Why? Because service A sends a request, some type of request, and service A needs to, then the service B will process that request and send in a response back. So in that sense, this becomes synchronous. Why? Because A sends a request and is waiting until they get a response back. The other and more natural way of doing this in microservices is using asynchronous communication. And the idea of asynchronous communication is, instead of getting two services to talk to each other directly, what we would do is we introduce another middleman in between. And that middleman is who we refer to as a message broker. The idea behind a message broker is we use something called the publisher subscriber pattern, where some service publishes a message, and we have one or many services that can subscribe to that message. So how the connection happens is, usually when you're publishing a message with message brokers, you publish it to some place called a topic. So in Kafka, we use something called, Kafka is a very popular message broker that is used. And in Kafka, we use something called topics. And the idea is we have let's use the same order service and the pay notification service example. So the order service will publish a message onto a topic saying, let's say, order completed topic. The notification service would be subscribing to the order completed topic with the message broker. And once a new message comes on that queue, it should be able to pick up that message and process it accordingly. So the order completed queue means the order has been completed. So notification service, all it has to do is send a confirmation email or something saying that this order has been completed. Why I said this approach is more natural with microservices is because this makes the connection between services loosely coupled. Why? Because one service doesn't directly communicate with the other service. All it directly communicates is with the message broker. So for some reason, if the notification service is down temporarily, we still can ensure that the notification will go because the message that would be published onto the broker, and the broker will try to reach the notification service. And if that is not up and running at the moment, the broker will take the message back and put it into some kind of retry queue so that it can retry. We can configure it to automatically go for another retry once the notification service is up. Whereas in a synchronous communication, if we had to get the order service to directly talk to the notification service, and it identifies that it returns a 500 internal server error. So then all it can do is probably log it, and it will have to take care of any retry logic by the services side. So that might be an extra burden on the order service or the caller service of this in this example. If you look at a very typical example architecture that you see in microservices, so typically I'm using the same example with the Synaptics of how they would have broken down services when they wanted to move into microservices. So we have a web client, which would be React, and we can use a API gateway. The idea of an API gateway is one thing, we can use it to route traffic that is coming in, because with microservices, once we distribute certain things, we have to have somebody to tell which request needs to go where, right? It's like when you go into a hotel, there's somebody in the reception. The receptionist needs, you would probably be asking like, where is the buffet at, or where is the room at, where is the pool at? You need to ask the receptionist where to go. So somebody needs to give you some kind of direction on where the traffic needs to go. So, and the API gateway is much more than that. You can use it to handle different requests from different types of clients. For example, in this case, what we have is a web client, but this application might evolve someday to use a mobile-based client. That's the idea of the API gateway. But the point is that, so typically I have segregated services as we have an authentication service, which will authenticate users. We have a user service, which will manage users. So users can log in, at the preferences of how they want to get notifications. The typical things that you would see in any social media type of application, some common services. So we'll have an order service, which can be used to order movies. We have a notification service. Then you can see it's an interesting, if you follow the arrows, the request comes through the API gateway and comes to the order service. And the order service actually doesn't directly communicate with the notification service. All it does is it publishes a message onto the broker, and the broker has a certain topic that the notification service subscribes to. And similarly, if you want to, so if I move into some of the benefits that we see, number one, it's easy to deploy. Why? Because now, if I go back onto the architecture, if there is some issue that has been identified in the user service, for example, we are not doing something right in the user service, we don't need to bundle and deploy the entire application again. All we need to do is identify the issue in the user service. That's an important step. You need to figure out where the issue happens. So given that you identify that it happens in the user service, all we have to do is bundle the patch the user service and independently deploy it onto wherever. So typically we try to maintain environments. So we have a test environment, a dev environment, a testing environment, a production likewise, and so on and so forth. So the idea is that we are easily able to deploy that individual component onto the relevant environment that we want to deploy it to. Selection of technology stacks. Now, technically speaking, these services are their own applications. They're not interdependent on each other at all. So for the movie recommendation service, the obvious choice for me would be to use Python, because Python has a lot of modules that can be supported in a machine learning type of machine learning applications. Similarly, if performance is of critical, there's nothing stopping me from using Golang to implement a notification service. If the user service is already stable and well established in our old .NET and we just don't have time to rewrite it, perfect, no issue at all. We can use .NET as a technology for that particular service. So this makes it possible for us to use the technology stack of preference based on each service that we are using. Same thing goes, since they are independent, the issues of dependency conflicts wouldn't happen here, because each service basically manages their own dependencies, and they can also have their own independent release cycles. You don't need to coordinate with everybody in the organization to come up with release cycles. You just fix a release cycle based on what fits your criteria. And it could be monthly, it could be sprint wise. any way that you think would be most applicable, you can very quickly fix things, improve things, and deploy it and make it available in production. So this also makes it easy to scale, and we are going to talk about scaling a bit more in the next slide, because it's really the technology that we use to do microservices in a meaningful way that plays a major role in the scalability aspect. And like I said, here we have the idea of a message broker. So services are loosely coupled with each other. They're not directly talking. They don't need to directly talk to each other. They can directly talk to each other, and that's a design decision that you would have to take. But we always have the option of going with this message broker. So this, that in itself is an architecture that we refer to it as event-driven architecture, which hopefully is something that you would be interested to learn more about, because it's crucial to understand event-driven architecture to use microservices in a meaningful way. If I quickly skim through some technologies that make microservices possible, of course, we're talking about developing server side, so we need some kind of programming language to start off with. Awareness of databases is also crucial. But what I really want to touch on is about Docker, because now when it comes to kind of deploying, let's think about the monolithic approach where we had one .NET big gigantic application. In order to be able to deploy it, we would have to do some provisioning on certain environments. We would have to install the .NET runtime. Maybe we are hosting it on the IIS, so we need to set it up, set up the application pools. If we are having a database, we'll have to set up the database. So there is a certain effort you need to actually do to be able to provision environments before we can actually run our applications on those environments. That too is not a difficult problem to solve with the advancements we've had. I mean, we have playbooks and Ansible playbooks and various other technologies that can help with it, but still it takes time and resources in order to do that. That's where Docker can help. So there's a famous quote that comes with Docker, which is that if it works on my computer, we can ensure that it works on any computer or any environment. The idea of Docker is we basically bundle our entire application that we try to do, we bundle it inside of what's called a container. So Docker is actually a containerization technology. And the idea of Docker is that we bundle it within a container. And what we deploy is that entire container in itself. So when we do that, the advantage is that if that container works locally on our computer, we are pretty much guaranteed that it would work the same on a remote server or any VM or anywhere that we're actually deploying it to, because we don't need to manually spend time provisioning and installing .NET and all of those things on those external places. All we need to do is ship the Docker container. Now, but of course, for this to work, we need to have a Docker agent set up in those in the remote environment. That is a prerequisite, but we don't need to worry of any other technology specific things that needs to be accounted for. So with Docker, we have to speak about Kubernetes as well. It's a bit of an advanced concept, but the idea of Kubernetes is that it's a container orchestration platform. So what it would help is, it would help you manage and handle your containers in a more meaningful and scalable way. So that's why I said the scalability aspect really plays a crucial role with Kubernetes, because you can use horizontal scaling to scale your containers that have been deployed. And Kubernetes gives you a lot of options and features like load balancing, for example, that you can use in order to make the implementation of microservices more meaningful. A very important feature of Kubernetes that I can mention about is it auto heals itself. So for example, if an application that we've deployed is for some reason is going to get degraded or is shut down, Kubernetes has a feature where it would kind of auto heal itself and try to get itself up again. So this is like kind of like, you can think of it like the Wolverine example, where he can auto heal itself. Same thing that Kubernetes can do. So we have a bunch of other technologies as well. All of it I won't be touching through, but one thing I want to mention is we talk about continuous integration. So the idea of building something, doing the coding part, creating a Docker image out of it, pushing that image onto what's called the remote Docker registry. That phase we can refer to as integration. And then the deployment part, we can accomplish that using Kubernetes, where we continuously deploy. So fix something or improve something, create the artifacts and push it to some Docker registry, and we can use Kubernetes to continuously deploy those things. So we use things like Argo CD as well to automate these things further. And then we also have the continuous monitoring. So that is a really crucial thing. Why? Because the moment we distribute our application into sub-services, what would happen is we need to monitor things. Like I said, these services are independently responsible to do their job, but we need to independently monitor themselves to make sure that these services are up and running, because they can, in some cases, be, although they're independent, in order to achieve a functionality. For example, sending a notification of after an order is confirmed and completed. They are independently doing that, correct? But in order to end, do the entire cycle of actually sending out the notification, there needs to be some level of communication that needs to happen from the order service and the notification service. So you need to monitor, and because if the notification service is down, that notification wouldn't be sent, and that functionality hasn't completed as per the expectation. So to do this, it's also another way of thinking about is it's if you do some kind of group project, you'll probably be taking updates from your colleagues you are doing that project with weekly or daily on some basis, right? You need to be updated on what they're doing, how they're doing, to make sure you're not duplicating the same thing, to make sure some guy is not sleeping and not doing anything. So you need to consistently be able to monitor it. So Prometheus is something that can help. Prometheus and Grafana dashboards, that is something that can help with the continuous monitoring aspect. Now, I just want to give you an overhead of those technologies, but absolutely it would be ridiculous if we talk about having somebody to learn all of these things just to get started with microservices. Which is why I refer to this as the hello world your way into microservices, which is really a simple thing that anybody can try if they have a little time that they can invest in to understand the basics of microservices and get a little feel of what this architecture is about. So number one, start with the basics, learn how to build a monolithic application properly, a proper client, a proper server, communication between REST endpoints. So try to understand that, how that works properly first. Once you do that, based on the criteria that I explained about, try to break those services into sub-services. And then start implementing one service at a time. So it can be the movie service that we spoke about, or an order service, a user service. One at a time, try to implement those services. And once you complete, then learn the basics of Docker. So with that, you'll definitely have to learn the commands that Docker gives you to pull images, to push images, to build a Docker image. How do we tag a Docker image that we're doing? So you have to learn the basics of that. And once you do that, learn the idea of Docker Compose, which is a way of basically spinning multiple containers over a single command. Once you're comfortable, so take your time to do this, because these are not things that you can learn overnight or in a couple of hours. Take your time to learn these things, and once you're comfortable with containerization, I would suggest you go through the basics of Kubernetes, understand the contribution, how you can use Kubernetes and Docker hand in hand, because they're not the same thing. They're spoken together a lot, but they're not the same thing. So understand how each of the role that each Docker and Kubernetes plays within an ecosystem like this. And then learn something called ingress. Ingress is basically a way that will give access into your cluster. So in Kubernetes, when we say we are deploying something, we typically deploy it to a cluster. So just learn a bit about ingress, because ingress is something that can help you put traffic into your cluster. And the next question is, so how do you do this? So first thing is, you don't need to invest in any cloud service providers. So at production level, we use things like GKE from Google, with the Google Kubernetes Engine, or AKS, the Azure Kubernetes Services. Those are all paid things, so you don't need to invest money just to learn these things. You can try out, one option is you can try out something called Minikube, which will basically give you a single node cluster that you can run locally. So try deploying something onto your local cluster. Another option is when you install Docker Desktop, which is a must, by the way, to work with Docker. That also gives you a free cluster that you can deploy things locally. So you don't need to spend any money with cloud computing services to do this. You can simply deploy things locally onto a local cluster. And you can use a command called kubectl, or we also call it kubectl. You can pronounce it any way you like. So you can use the kubectl command. You don't need any fancy build pipelines and automated pipelines to do this. Just manually use the kubectl command to do the deployments onto your local cluster. And once you're comfortable with that, over the ingress, you should be able to expose a few public endpoints that a client can use to communicate. And certain services might remain as private services accessible only within your cluster. So that's a good practice that you want to maintain. If your service doesn't need to be exposed publicly to a client, then don't expose it publicly. Just keep it private within your cluster, because that's a good practice security wise as well. Once you've gotten the hang of it, then move into the understanding of event driven architecture, what a message broker is, and how a message broker can fit in within this ecosystem. So just like every coin has a flip side, microservices also has a few challenges, and one probably shouldn't surprise you, which is the idea of synchronizing data across data stores. Why? Because I said in order for a microservice to truly function independently, it will probably have its own database, which means sometimes based on other events that happen in the system, that data store needs to be updated continuously. So there are various patterns and best practices that you can adhere to and adapt in order to make sure that happens properly. But that has been known as a challenge within microservices. Another part is setting up the initial infrastructure can be difficult and also time consuming. Why? Because there's a lot of technologies that you need to be aware of. That also maps to my fourth point. Actually, there's a bit of a steep learning curve to learn how these things work, how the communication happens, how we expose services outside, what a private cluster is, all of those things. So it can be a little bit difficult to set up the initial infrastructure. And of course, the continuous integration and development, continuous integration and deployment process is complex. Why? Because in a monolithic system, we have one gigantic application, right? So if you figure out a way to continuously integrate and deploy that, that's it, right? So that problem is solved. With microservices, we are breaking it down to multiple small applications, which means each small application needs to have its own CI/CD pipeline, its own continuous integration and deployment process. It needs to have their own things figured out. That means what was one problem within a monolithic system is actually now going to be distributed. So it's not an extremely difficult problem to solve, but it can have some complexities because you have to do the same thing that you're doing across multiple different applications. A final takeaway that I want to leave behind. So it's a nice quote that I saw, which says that it's not the destination, but it's the journey. So the only thing I want to leave behind is, if you look at the movies, the Cineflix example that we saw. So they started off with a terminal-based application. Clearly, that wasn't a good solution given the advancements of technology that we've had. So then they moved into a 3-tier architecture. Once they moved into a 3-tier architecture, we saw the various endpoints that they had defined, and they were still deploying the application tier as the entire monolith. What I want to say is there's nothing wrong with a monolithic application. It's just the choice of whether you need to go for a monolith or a microservice solely depends on the requirements and where you see your product is headed towards. So just because microservices, like I showed you some statistics, 82% people are using it, 92% of people like it or something like that. Just because there are some statistics, don't think that you need to, microservices is the architecture that will fit all problems, because like we saw, it's not a silver bullet. It does have its own limitations. Yes, certainly as technology advances, it does try to address certain limitations that we saw in a monolithic application, certain things with regard to scalability, the flexibility that we get for deployments. So all of that have been addressed with microservices, but you often have to put the pros and cons on a scale and see which one would suit the best for your product and where it's headed. So don't think that just because microservices might be a bit trendy, not that I want to use that word because it's not a new thing per se, it's been here for a while now. But just because it's gaining some popularity lately, don't think that's the best architecture. There's nothing wrong with monoliths as well. You just need to identify which one suits best for your product. And the other thing about this being about the journey and not the destination is you'll only learn microservices. I can assure you. So we had this webinar today. You can go on YouTube. There are hundreds and hundreds of great talks, great presentations. A lot of people have done on microservices. So you can watch all of them even. But I can guarantee you will never learn microservices until you actually implement something and see it's not going to be a walk in the park implementing microservices and deployment. You get a lot of errors, things will fail. It'll be pretty frustrating at the initial setup because there is a steep learning curve, but you will never really understand it unless you get some hands-on experience. And at the end of the day, it's not about monolith or microservice. At the end of the day, it's about adding more skills and technologies under your belt that you can use to solve a variety of different problems. So you need to have a mindset of a problem solver and not just some person adapting to architectures as they come. Use those technologies and use the proper technology to solve the proper problem. And in order to get an understanding, you'll only get it by actually implementing and building something with it. So it doesn't need to be anything big. Build something as small as possible, and that'll be good as well. That's it from this presentation from us. So thank you so much for your time. We hope that it was something insightful for you to hopefully try out this architecture. So maybe we'll see you guys back in another webinar. Thank you so much.